Well, it's time for our next talk. Our next talk is by Andrey Meshkov. Andrey has been involved in ad blocking for a very, very long time. He's the co-founder and CTO of Adguard and has immense knowledge in the field. We're honored to have him. He's going to talk about DNS-based content filtering, and I'm really excited to have him. Over to you, Andrey.
Hello, everyone. Hopefully, you all can see me. And let's start, I guess. So my name is Andrey, and I'm a co-founder and the CTO at Adguard. Adguard is a popular content blocking tool available for every platform. But besides that, we're also running one of the most popular public DNS resolvers. And the main feature of our resolver is that it does content blocking. So that's what my today's talk topic is about, using DNS for content blocking. Why did I choose this topic? You see, DNS has been developed really rapidly in the last couple of years, and these changes contributed a lot to the popularity of DNS content blocking. And today I'd like to explain what it is, how it's done, what problems we have, and maybe what awaits us in the future. Let's start with a simple thing. This is a developer summit, so I suppose that most of the listeners are quite technical and understand what is DNS and how it works. But anyways, I prefer to have at least a brief introduction to what DNS is. Well, DNS stands for Domain Name System, and its purpose is to translate websites names, domain names basically, into something browsers can understand. And this is IP addresses. You see, on the internet, most of communication happens over TCP and UDP protocols, and these protocols, they do not know anything about any names. They only operate IP addresses. So if you need to go to a website, your browser or any other app should first figure out the IP address of this website. And in order to do this, it sends a special DNS query to a special server, which usually is provided by your internet service provider. And this server is called a DNS server. So how DNS level blocking works? It's very simple. It is called DNS sinkhole approach, which actually means handing out non-routable addresses for the domains we want to be blocked. And the apps simply cannot connect to this address, and we have the desired result. The connection is prevented. In some cases, this might not be enough, and we have to resort to using some complicated things like rerouting the query, the connection to a proxy that implements additional filtering. But well, in 99 and 99% of cases, DNS sinkholing is what is being done. Technically, here's how it works. Let's take a look at some real examples. So you can see on this slide a screenshot of me doing a DNS query for a blocked resource, and you can see that the DNS server just responds with the zeros IP address, and well, the app cannot connect there. Other options are responding with special responses, an X domain, which means domain does not exist, or refused, which means the server refused to process the query. Both of these options are viable, although some old devices may misinterpret refused and try to use a fallback DNS server. So for now, zeros is a safer option for DNS sinkholing. So this is a brief introduction into content blocking. But before we continue and continue to the at scale part and all this stuff, let's take a brief look at the history of the question. Surprisingly, DNS level blocking is actually the oldest known approach to ad blocking. Well, how is that possible, you would ask? And to answer that question, let's talk about hosts file. Hopefully you know what it is. But, well, this is basically a predecessor of DNS. Back when there was no internet, there was only ARPANET. In these days, a naming system was created that would map a computer's IP address to a unique ASCII-based identifier, known as domain name now. With only a few computers linked to ARPANET, the Network Information Center maintained a single file named hosts.txt. This was a master list of each computer's address and its host name. And so system administrators would download hosts.txt periodically, manually. And if you knew any ARPANET computer's name, you would look it up in this host file and then connect to it. But it soon became clear that the exploding number of hosts was putting too great a load on this central computer, because everyone wanted their computers on ARPANET, but they had to wait for Nick to update hosts.txt, and well, it wasn't suitable. Something else was needed. So in late 1987, Paul Moka-Petris outlined the domain name system. So what we know, what we all use now. So thanks, Paul. You're great. And on this slide, you can see how the ARPANET hosts.txt file looked like. It a little bit different from how it looks right now, but well, some similarity. There is some similarity. However, the host files, they didn't disappear. And to these days, every operating system has it and consults it before making a DNS query. And if there is a line matching the domain name you want to connect to in the host file, the operating system will just use this line instead of questioning the DNS server. And so when soon after the first internet ads appeared, people discovered that the host files can be used to prevent downloading of the ads using pretty much the same DNS syncholling approach I was talking about. Once this was discovered, there were people who devoted lots of their time to maintain the very first block lists and well share them with everyone. I would like to mention some notable block lists with more than 20 years history, or maybe something about 20 years history, which are still actively developed to this day. First, it's Peter Lowe's block lists, and kudos to Peter. He will be talking on this summit as well, so please listen to him. And then there's Stephen Black's block list, and Dan Pollock's host files. These people, they made a huge contribution to content blocking, and they should be remembered and well respected. There are actually more people, but well, the space on the slide is limited. Thank you, all of you. So then, host file approach became rather popular and did the job quite well. And even when the very first version of Adblock for Firefox appeared, some people simply didn't understand the purpose. They were just happy with what host file was doing for them. Well, however, there are some issues with the host file that aren't easy to solve. And first of all, this is distribution of updates. There is no good way to distribute a host file to the users. You either need to have a piece of software do it for you, or maybe you need to be very patient and periodically do it manually. This issue is what led to invention of DNS in the ARPANET days. So, well, you can see the connection here. And the second issue is that host files tend to be huge, since you cannot use wildcards or regular expressions, and you have to list every domain there. Well, the host file syntax is simply not supposed to be used for content blocking. And well, on the slide, you can see one of the largest block lists that I know, Energized Unified, it's called. And as you can see, it contains over 700,000 domains and weighs like about 21 megabyte. And well, distributing a 21 megabyte file to millions of users daily is quite a serious problem. So DNS is a logical solution. And that's how the very first public DNS service that block ads appeared. It was enough to configure the device or the router to use such a server, and users didn't need to deal with host files updates anymore. One of the first public DNS servers that was doing that was called, and is called, actually, it still exists, is called Alternate DNS, and it appeared, I think it appeared in 2015. Yeah, it was maintained by a single person, some kind of a side project. So, well, and that's great news. A lot of content blocking is done not by companies, but, well, by regular people. And this is great. We have a community. But later in 2016, we also launched the DNS server called Adguard DNS, which is still active and very popular. I will be talking about it a little bit later. But why DNS? Before talking about, before talking about at scale, why DNS? What's so good about it? DNS level blocking is inferior in some aspects to other approaches. So why do people still want to use it? And before answering this question, I would like to talk about what a perfect ad blocker is. Actually, it would be correct to describe an ad blocker not as something that just block ads. This is basically an internet enhancer. Without it, the web is aggressive and intrusive and consists of a bunch of scattered pieces that each fight for your attention and try to distract you from the content you came for in the first place. And the perfect ad blocker is not defined by what it is, but rather by what it produces, that very best version of the internet. And second point is that the internet is bigger than just browsers. The internet is everywhere, and ad tracking is where the internet is, so it's everywhere as well. Computers, mobile devices, smart TV, etc., etc., etc. With a browser ad blocker, you just get a tiny window to the better internet. And well, it's not enough for me to have a framed window to the best internet. Absolutely everything is connected to the internet these days, so why would I limit myself to just one browser? So does DNS fit the perfect ad blocker definition? On one hand, DNS is indeed capable of widening the window to the better internet. Unfortunately, due to its limitation, it cannot provide the same level of quality as browser-based blockers. But the widening the window point is still enough to make DNS level blocking very, very popular. And let's take a look at some stats. So browser blockers might be the most popular among casual users, but not among filter list maintainers. There are way more host files and domains lists maintained by volunteers than the filter lists for browser-based ad blockers. Well, you can see on this slide some stats that I collected from filterlist.com. This is a signal that DNS level blocking has great perspectives. But why such discrepancy? Among casual users, DNS blocking is really just marginal compared to browser-based blockers. The answer is simple. It is still much, much harder for a casual user to set it up and to use it. So, well, before the last couple of years, DNS as a standard was almost frozen with only slight changes. But then it all exploded with new standards. And the main theme, the main topic is DNS encryption. DNS over TLS, DNS over HTTPS, DNS over QUIC. They all became mainstream. Operating systems, one by one, started adding native DNS encryption support. Okay, got it. DNS encryption is great. But what does it have to do with content blocking? Let me try to explain. Before DNS encryption became popular, the options were too complex for for a casual user. You could use a host file and somehow receive updates to it. You could use a plain DNS server, but there are limitations. For instance, on mobile, you could only set it for Wi-Fi. On desktops, you had to configure every network adapter and dive into some quite low-level settings to do that. This is rather complex, and someone like my mom, for instance, wouldn't be able to do that. Well, or you could use a VPN, but this requires installing additional software, so no go. And after DNS encryption became mainstream, some technical obstacles simply disappeared. You now could configure a DNS server once. It would be used on any network. Granted, you still need to dive into some device settings, but not as deep as before. And this alone gave a huge boost to DNS blocking solutions' popularity. So one more thing that also helped is the concept of DNS name. The concept of a domain name that is used in DNS encrypted service allowed applying some custom rules based on the DNS server's domain name. In the past, that was only possible by linking the user's IP address, which is like hardly a good solution. But now public DNS servers can provide users with customization options, which basically means that the users may choose what to block and what to not block and continue to use the public resolver, which is like cool. But using DNS content blocking has also some obvious flaws, and I would like to talk about that as well. But first, I want to talk about advantages. Using DNS does not require installing additional software. It does not depend on the browser or operating system vendor. This one might be important, so browsers and operating system vendors sometimes change their rules, and we have to abide with DNS level content blocking. You are independent. And also one more thing for users, no performance cost for the user. Everything is done on the server side. And finally, the last one of the last points is a centralized solution is better at dealing with some issues. I will talk about it a little bit later. And also one more thing that is important for someone who runs and maintains a block list. Running a public DNS server allows you to observe the whole internet. This is very useful if you maintain a block list. You can get rid of unused rules, promptly learn about new threads, and DNS has no blind spots. Like, well, in the browser, you only see what browser connects to. You cannot see what apps do, what your smart TV do, and DNS has no such blind spots. You see all the internet. And a couple of examples of things that are better to deal with on the DNS level or by a centralized solution. One example is CNAME cloaking. This is a tactic that was employed by some trackers to hide from blockers. By the means of a CNAME DNS record, they were hiding the real third-party domain name, disguising it as a first-party domain name. And with Adguard DNS, we were able to find out most of these disguised domains and publish a list of them so that even content blockers with no access to DNS could stop this. And I've seen the summit program, and I think there will be Yana Dimova will give a more in-depth talk about that. So please attend. One more example is using proxies for disguising trackers. What it means is that you can use Cloudflare or CloudFront to configure a serverless proxy that would hide the original third-party domain. Just like CNAME records, but this time it is not that visible to DNS, and DNS in general cannot help you fight this. But it can be a good starting point to detect such proxies, and detecting such proxies is better be done using some centralized solution, like server-side solution. And now it's time to talk about disadvantages. And there are some quite important ones. First of all, DNS cannot deal with first-party ads. For instance, you cannot block YouTube ads because they are hosted on the same domain as legitimate videos, so no go. Second, DNS has no cosmetic filtering capabilities. Cosmetic filtering is crucial to the quality of content blocking. So with DNS blocking alone, you may not have most of the ads, but you have rather ugly web pages with broken frames, ad placeholders and stuff. And third, DNS blocking is not flexible. You either block a domain or not block it regardless of which site or which app wants to connect to this domain. And for instance, some apps or websites may be broken due to blocked Google Analytics, for instance, and you can do nothing with that. And finally, it is easier to circumvent DNS level blocking. An app may simply choose to use a different DNS server, for instance. Some flaws of DNS filtering might be fixed or at least mitigated in the future, and there are some new standards that are currently in development that could help. Let me talk about that. Currently, if the domain is blocked on the DNS level, you just see an ugly error page. This hurts the user experience. For instance, they might want to temporarily unblock it, and there is simply no way to do that. Fortunately, there's a new RFC about DNS access denied error page that will allow showing a beautiful blog page to the user without resorting to ugly solutions. Second, DNS discovery. I see that I have not a lot of time, so I will try to be faster. So now, DNS discovery is important so that you could stick your encrypted DNS up on the router and be happy with it. And finally, one more thing that can be improved that we would like to work about is app detection. There is no RFC that could help us, though we can try to do it ourselves. We need to create some kind of a DNS fingerprints or network activity fingerprints, at least for the popular apps. If we knew what app makes a DNS query or makes a connection attempt, we could be more flexible about what is blocked and what's not. For instance, block Facebook in non-Facebook apps, but keep them working in Facebook apps, in Instagram and stuff, so that the apps didn't broke. Well, creating these fingerprints requires analyzing traffic, network behavior, and we're working on a solution that will do it. This might become the topic of my talk next year, hopefully. Finally, the at scale part. And everyone loves at scale solutions. This is a very good buzzword. So we will take a look at Adguard DNS as an example of a blocker that scales to millions of users. What it is right now. So it consists of multiple servers located in 14 locations. All these servers announce the same IP addresses via BGP. Its current load is about 300,000 DNS queries per second, and about 75% of the DNS traffic is encrypted. This is actually what differentiates content blocking DNS servers from others. If you take a look at Cloudflare DNS or at Quad9 DNS stats, you will see that encrypted DNS is just a small share of all queries. But for content blocking DNS, this is very different. Most of the traffic is encrypted. Adguard DNS is written in Golang, and it uses block lists composed using special DNS filtering syntax, which I'll describe a bit later. Each Adguard DNS node consists of several parts. On the front end, we have a DNS forwarder written in Golang as well that implements all the logic. By logic, I mean DNS filtering, caching, etc., etc. On the back end, we have an unbound server instance which provides DNS recursion capabilities. A single server node load is about from 5K to 40K requests per second, depending on the node location. Some locations are more popular than others. And a few words about the block list we use. In the very beginning, we weren't too happy about host files because of their limitations. Host files are not supposed to be used as block lists. Their syntax cannot be extended. So instead of that, we decided to build up our own block list syntax. And we based it on something we are very familiar with. And by that, I mean the standard Adblock style syntax that can be extended via adding custom modifiers. And it was then gradually improved and extended with time. And on this slide, you can see some example rules that could be used by Adguard products. Not just Adguard DNS is capable of evaluating these rules, but also we have Adguard Home and all the other products, they all have DNS filtering. And just to demonstrate you the difference, on the left side, we have stats for Adguard DNS filters. This is what we use by default. It has like 40,000 rules. And daily, it blocks about like 900,000 domains. And on the right side, we have an old style host file energized ultimate, which consists of 500,000 domains. And it blocks 500,000 domains. So despite the size, it performs worse than Adguard DNS filter. And DNS filtering engine implementations are available on GitHub. They are open source. There are 2 libraries that you can use if you want to. There's URL filter. This is the library written in Golang that we use in Adguard DNS and Adguard Home. And there's also Adguard DNS libs and a different C++ library that we use in our client apps. Besides DNS filtering, it also provides DNS encryption implementations. This is a slide about performance. Just believe me, performance is great. And finally, a couple of predictions. So here's what I think what awaits DNS content blocking in the future. First of all, the growth of DNS content blocking will accelerate. We estimate it at 10x right now, but it won't stop there. Windows 11 brings DNS encryption support. The new routers also support DNS encryption. This all will make it easier for the users to set it up and use it. Circumvention of DNS content blocking will increase, but it will still be marginal. It takes a lot of effort from different parties to circumvent it. And for that to start happening, DNS content blocking should be as popular as browser blockers, which I don't think, to be honest, will happen despite the growth rate. And DNS will not replace browser-based blockers, but still, it is here to stay. Thank you, everyone, for attention. And if there are any questions, I would be happy to answer.
Hey, thanks, Andrey. That was really awesome. As always, I love that whenever you come to the Adblocker Developer Summit, there's also like a really cool sort of behind the scenes sort of history behind ad blocking and filtering. So that's always fun for everyone to learn. We don't have that much time. We just have 1 minute. So I have one question, which is, when it comes to DNS-based ad content filtering, your journey over here, what has been the most surprising thing to you when solving this problem?
Is it about ad blocking in general? So the most surprising thing that I encountered while doing ad blocking, like for these 10 years? Oh, that's a hard question to respond. You know, I will try to think up something and then write to Slack, because this is really not an easy question.
All right. With that thought, thanks, Andrey, once again, and see you in Slack and in the chat as well. Bye.
Thank you, everyone.